Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 5, exponents, polynomials, and polynomial functions. I think so far we covered section 5.1 through 5.5. The last video, we took a look on the greatest common factor and factoring by grouping. We use factoring by grouping to factor four-term polynomials. But in these sections, right here, what we're going to do, we would present techniques for factoring trinomials. For example, let's suppose in the previous sections, if we have x plus 3 times x minus 2, for example, we know, we can what we can do here. Remember what we did. If we do FOIL, if we FOIL it, what did we do for FOIL? In one of our videos, we multiplied the first. That gave us x squared. Okay, and we multiply the last. That gives you negative 2x. We multiply the inner, the inside, and we multiply, we multiply the first, the outer, the inner, inside, or now we multiply the last, that gives us negative 6. So when you do that, when you simplify, it gives you x squared plus x minus 6. So now our goal, let's say that x plus 3 times x minus 2 is a factored form of x squared plus x minus 6. Taking a close look at how x plus 3 and x minus 2 are multiplied suggestion a pattern for factoring trinomials. As you can see, we can say that it's really give us something. So what we're gonna do, that's exactly what we're planning on doing here. Develop techniques on how we can factor trinomials on the form x squared plus bx plus c. Usually trinomials is in the form ax squared plus bx plus c. But when a is equal to 1, then we get to the first objective, only x squared, because if a is 1, we have only x squared left plus bx plus c. But we would also factor trinomials where you're going to have ax squared plus bx plus c, where a is not equal to 1. So a can be equal to 2, to negative 5, but at least we're going to do that. There are two methods, one trial and check and one by grouping. That's we would call also the AC methods. And also we would factor by substitutions. Now, we said if you have x plus 2 times x plus 4, when you when you FOIL this one, what it gives you exactly. So that's what we're trying on showing you here. If you FOIL, remember FOIL, this one would give you x squared, 4x, 2x, 8. Now we have x squared plus 6x plus 8. Okay? So we would say factoring trinomial source from x squared plus bx plus c is what it would be. Now, factoring trinomials on the from x squared plus bx plus c, where a is equal to 1. As we said, to factor these trinomials, what you need to do, you need to find two numbers. When you multiply them, it gives you c. When you add them, it gives you b. Look at the previous examples, right? If I have x squared plus 6x plus 4, you said, what are the two numbers? If you multiply these two numbers, it gives you, oh, sorry, that's 8. If you multiply these two numbers, it gives you 8, but when you add these two numbers, it gives you 6, right? You need to think about it. Once you find is 2 and 4, 2 times 4 give you 8, and 2 plus 4 give you 6, then you know this one will be factor x plus the first number times x plus the second number. So x plus 2 and x plus 4. So that's why we get this one, all right? So what we mean, note that B is the sum of the two numbers and C is the product of the two numbers, right? So we will be looking for two numbers whose product is C and whose sum is B. Now there are very few choices for the product, so that's why we start with the first one. So if you prefer to do that, but no, we have 30. We want to obtain 30. Two numbers, when you multiply, give you 30, but when you add these two numbers, it gives you 13, right? Yeah, that should be 3. And 10, 3 times 10 is 30. 3 plus 10 is 13. So because you have this, so since our two numbers must have a product of 30 and a sum of 13, the two numbers must be positive. As you can see, they are all positive. If one of, let's suppose the product, I mean, the C term is negative, then you can expect one of the numbers will be negative. But if the last term is positive, both numbers will be positive. So that's why we obtain these three. We could make a list of numbers. 1 times 30 make 30, 2 times 15 make 30, 3 times 10 make 30, 5 times 6 make 30, but the only one that would make it 30 and when you add them give you 13 is 3 and 10. So that's why you would factor x plus 3 times x plus 10. And that's it. You know, all our products would be the same. Two numbers, what we need to know, since our two number must have a product of 24, remember you need to multiply two numbers to obtain 24, and you must obtain a sum of negative 11 when you add them. Because the number in the middle is negative, and the last term is positive. So you obtain positive only when you multiply two positive numbers or when you multiply two negative numbers. Because if you multiply two positive numbers to obtain 24, when you add these two numbers, you cannot obtain negative 11. So you would assume the two numbers you would multiply to obtain positive 24, these two numbers must be negative. So we know 24, 2 times 12 give you 24, but when you add it, give you 14, not working. 3 times 8, 24, 3 plus 8. Yay, 11. So you know it should be negative 3 times negative 8. Two negative in multiplication give you positive, but when you add two negative numbers, it gives you negative. So we would conclude that anytime you see x squared minus 11x plus 24, you can factor it as x minus 3 times x minus 8. If you want to FOIL with this and make sure you obtain the same answer, let's FOIL. Remember, FOIL meaning multiply these two, that's x squared. Multiply these two, that's negative 8x. Multiply these two, negative 3x. Multiply these two, that's positive 24. So we have x squared minus 11x plus 24. Okay, so that's it. That's it. Now, let's suppose for this one, x squared minus 2x minus 35. Okay, now x squared minus 2x minus 35. All right, now what are the two numbers? When you multiply, give you negative 35. At this point, you know one of the number must be negative. Okay, because in order to obtain a negative from a product of two factors, one of the factors must be negative. So that's what we do. We at this point we need to obtain negative 2. So at, when we find these two factors to multiply to obtain negative 35, the largest number must be negative because our expectation is to obtain a negative number, which is -2. Now, 35 has only two factors. I mean, 1 times 35. If you do a negative 1 minus 35 would be -34. You don't need 34, but you have 5 times 7, so you can have 5 times -7 or -5 times 7. So because we need -2, we can say it's -7 times 5, give you -35. -7 plus 5, give you -2. So you can conclude that x minus 7 times x plus 5 are the two factors that you can multiply to obtain the trinomial x squared minus 2x, minus x squared minus 2x minus 35. If we continue to do more exercise in this category, we need two numbers when you multiply give you 10. When you add these two numbers, it must give you -6. So we know the two numbers must be positive or must be negative in order to obtain -6. But in order to obtain negative, what are the factors that would give you 10? Only 1 times 10 or 2 times 5. Note that if you do 1 times 10, -1 times -10, that would be when you add -1 plus -10 would be -11. If you do, because this one doesn't work, so you cannot obtain -6 with it. If you do -2 times -5, of course, that gives +10, but -2 plus -5, that gives you -7. Okay? So at some point, -7 is not -6. So we look for two numbers whose product is 10 and whose sum is -6. The two numbers will have to be both negative. So negative factors of 10 is -1 times -10. The addition would be -11. -2 times -5, +10, but the additions will give you -7. Since there is not a factor pair whose sum is -6, you can say that x squared minus 6x plus 10, you can just say it's prime. Or you can say cannot be factored. Okay, cannot be factored. It's prime. Okay, not all the time you can, you can factor trinomials, right? Now, check results is very important. You should always check your factoring result by multiplying the factored polynomials to verify that it's really equal to the original polynomial. So that's very important to verify. Many times you can detect computational errors or errors in the signs of your numbers by checking your results. So if we try to do more examples, look at this one. Oh my God. First of all, there's a combinations between the GCF here. If you look at that, the GCF, the greatest common factor, there is 3, 3, and 3 because 24 is 3 times 8, right? And 60 is 3 times 20. So if we factor, the 3 is 3 times 1. So if we factor out 3, we have left m squared minus 8m minus 20. Now, you see I factor out the 3, but we still need to go somewhere and factor this one, m squared minus 8m minus 20. First of all, two numbers when you multiply give you -20. When you add it, give you -8. One of the number must be positive. One of the other number was negative. So 20 is 1 times 20. 2 times 10. Oh, yes. 2 times 10 would give you 20. 10 minus 2 would give you 8. So in this case, we're going to say -10 times 2 give you -20. -10 plus 2 give you -8. So we can conclude that this one right here would be m minus 10 times m plus 2. So coming back here, we can say it's 3m minus 10 times m plus 2. Okay, m plus 2. So we try our best to, first of all, factor out the greatest common factor 3 from each term. Now, because the two factors that whose product is negative 20, whose sum is negative 10, they are negative 10 and 2, then we do that. Now, as you can see, the first five examples, they are all about trinomials in the form x squared plus bx plus c, or I can say ax squared plus bx plus c, where a is equal to 1. So we do only x squared plus bx plus c. In this case, what we did, find two numbers whose product is c, whose sum is b. Okay, then we factor with this one. But now what we're gonna do is try to factor trinomials of the form ax squared plus bx plus c, okay, where a is not equal to 1. Now, even though you try, you see there is no common factor between these four. Of course, 20 and 4 has common factor 4, 25 and 20 has common factor 5, but 25 and 4 that has no common factor. So we cannot factor out, right? Now, when we deal with trinomials in the form ax squared plus bx plus c, all right, where the coefficient of x squared is not 1, then there are two methods. The first one is doing the trial and error. So we can try as many as possible. First of all, we know we're going to have two factors. And we can say, you know what? What are the two numbers when you multiply give you 25? Well, 25 can be 5 times 5 or 1 times 25. We're going to try with 5 times 5. So if I do 5x times 5x as the first term in the first binomial, in the second binomial as well, 5 times 5, these two numbers right here, when you multiply it, give you the 25x squared. So we're good with that one. I mean, we don't know yet. You can either work 1 times 25 or 5 times 5. We're going to try 5 times 5. Now, the second one is to go with, first of all, I try to write this term. Now, let's try to write this one. What are the factors of 2? 1 times 4 or 2 times 2? If you try to put 2 times 2 to make it positive, now you need to verify. You know what? I'm going to do 1 times 4 first, so just you can see. If I do 1 times 4, make it 24, I'm going to try something. Look, this one right here give me 5x. And this one right here give me 20x. So if I take 20x plus 5x, it gives me 25x, which is not determined in the middle. I need to make sure the way you see it right there, the sum of these products give me 20, determined in the middle. But that's not the case if I do 1 times 4. I'm going to try 2 times 2. For what two factors when you multiply give you 4 is 2 times 2. I know 2 times 5 is 10x, and the other 2 times 5 is 10x. Now, if I take 10x plus 10x, it gives me 20x, which is the term in the middle right there. So we can conclude that we can factor that GCF, that's trinomials as 5x plus 2 times 5x plus 2, or you can simply say it is 5x plus 2 power 2 because it's the same. All right. So that's what we call trial and error. With the trial and error, you try to see which one would give you the answer. Now, so many techniques we can use, but you know what? We can follow them one by one when we do those techniques. All right. But factorial trinomials of the form ax squared plus bx plus c, Write all pairs of factors of ax squared, like 25x squared. I know it would be one x times. Like when I say 25x squared, I know it can be x times 25x, give me 25x squared. I can do 5x times 5x. That's the one I try first. But fortunately, it's working, but not all the time. That's why we say trial and error. Write all pairs of factors of C. The constant term, for example, here, when I took 4, I know 4 could be 1 times 4 is 4, 2 times 2 is 4. So I try these two. Try various combination of these factors until the correct middle term B, bx is found. That's what I do. These two plus these two give me 20. Then I said, that's it. I'm done. Okay? So I said, I'm done. Okay. I don't know why. Oops. Okay, you know what? It's refused. Oh God. Okay, I don't know what's. Okay. Is it? I think that's. Sorry. Okay, usually it's do that to me. I'm gonna see how many I can do. Probably try to, because I have so many examples I haven't covered. It seems like it's freezing. I'm gonna try this one, but look at this one. When I take 21x squared, I can say I take 3x times 7x, give me 21x. I can say also x times 21x, give me 21x squared, right? If I take 10, 1 times 10 give me 10, and 2 times 5 give me 10. Now, different ways of trying it. If I do 7 times 3, 3x times 7x, okay? Now, what's going to happen with 10? Because our goal is to obtain negative 41. And I realize the two numbers for 10 now must be negative. So it's like I have negative 1 times negative 10 or negative 2 times negative 5 to obtain 10 because I need determine the middle to be negative. Now, in order to make it negative, if we follow the same, we're going to do negative 5 and negative 2 because remember these two give you negative 35 x, and these two give you negative 6x. So negative 35x plus negative 6x give you negative 41x in the middle. So that's how we need to factor what we have. Now, I'm hoping I can, for some reasons, it's freezing a little bit, and I am unable to stop it. I think what I'm gonna do is really let's see, it doesn't change anything. Okay. Um let's see what would happen if we go back and save probably. Maybe I don't need to redo everything. Okay. No, doesn't help for anything. If I insert a slide, I think it's really freezing. Let's suppose I stop sharing and I share it again. I'm gonna try, just cut it a little bit and come back and try to clean it up. No, that doesn't work. So what I'm gonna do is really stop the recording and come back to uh, continue with the same chapter. I apologize for the any inconvenience. Take care.